Today we are going to talk about asymptotes, both horizontal, vertical, and slant asymptotes. Okay, so whenever you get any particular function where there's an x, any particular x in the denominator, bad things can happen. What do I mean by bad things? Well, you can end up divided by 0. Paige? Yeah, here, grab these. I want to pass those back to them. So one of the things you do not want to do is you don't want to divide by 0. Cookie Monster told us it's a bad thing. If you divide by 0, you have no cookies and you have no friends. So let's see what Cookie Monster means. So first of all, what I would do in this case is I would factor right off the bat. If it factors, I will definitely factor. So I'm going to rewrite this as f of x equals, I'm going to go on x plus 3 and x minus 1, because that would give me multiples of negative 3 that add to make a middle term of 2. And in the denominator, I'll factor this to be an x minus 4 and an x plus 3. Okay. Now, what we want to do is look at the denominator. Okay. So let's look at the denominator. And the denominator has 2 possible problems. All right. So if I look at the denominator, we want to make sure the denominator can't be 0. Can't be 0, right? So if I look at that, one of the things I see right at the bat is if x equals 4, we're in trouble, or if x equals negative 3, we're in trouble. Okay, these are both bad things. So really what we want to do is make sure that x does not equal 4 and x does not equal negative 3. Because if x equals 4, 4 minus 4 is 0. You divide by 0, bad things happen. Okay, if x equals negative 3 plus 3, you get 0, bad things happen. So what's going to happen? Well, one of the things that happens is the 3 is removable. Okay, so I can remove the x plus 3, and since I can remove the x plus 3, I can cancel, right? And if I can cancel or remove it, then what happens is we're going to have a hole. So we're going to have a hole, if it's removable, at x equals negative 3. Okay, so we're going to have a hole because we can remove the x plus 3. And that problem is gone. However, in the original problem, it is there. We can't just cancel it out. So I know for sure I have a hole at x equals negative 3. Negative 3 is something, okay? But the negative 4, the x minus 4, cannot be removed. There's no way you can factor that or cancel that. So what happens at x equals 4, since it's non-removable, you're going to have a vertical asymptote. So right off the bat, the first thing I'm going to graph is at positive 4. I'm going to go 1, 2, 3, 4. And I'm going to draw in my vertical asymptote for sure. Now my hole, where is my hole? Well, you can't plug in into this equation. You can't plug in the negative 3. But if you cancel it out, you will be able to. So if I take my equation, if I want to find out where my hole is. So to find hole, find the hole, let's cancel. Let's change this problem to an f of x equals an x minus 1 over an x minus 4. And now I can plug in the 4, right? I can plug in, no, not the 4. I can plug in the negative 3. So my bad. I can plug in the negative 3 because that's where my hole is. So once I cancel out my problem, I can actually plug in the negative 3 now, and I can find out where the value of my hole is. So, okay, so f of negative 3 would be a negative 3 minus 1 over a negative 3 minus 4, which gives me a negative 4 over negative 7, or 4/7. So my hole, I'm at negative 3, hold on, 1, 2, 3, my hole is right about here. All right. Let me erase that. Okay. So the coordinate of my hole is at negative 3, 4/7. That is where my hole is. But you got to keep in mind that that hole does not exist. I mean, technically, if you were to walk to this exact spot, you in a sense fall through the hole. Okay, if you go. And how I ended up getting the y value is I canceled out the problem. I removed it. Right. Once I removed it, I got the rest of the function. I was able to plug in the negative 3, and I got its y value, even though it does not exist. Once we graph this on the calculator, you'll see where it's at, but you will not be able to get 4 sevenths because it doesn't exist, right? It's a hole. Now, what about the horizontal asymptote? So let's look at the horizontal. Okay, to do the horizontal asymptote, we got to think about what's going on. The horizontal asymptote is where x goes to infinity. It's going to like flatten out. Remember we saw in the calculus we trace and trace and trace. So as x approaches infinity, it's going to flatten out somewhere. So that's where we're going to let x approach infinity. So we're going to let x approach infinity. So let me go back to my original problem, and let's go ahead and plug in infinity. So my original function was f of x equals x squared minus 2x plus 2x minus 3 over x squared minus 1x minus 12. Okay, and if I plug in infinity, approach infinity, then we're going to be able to gobble up. Remember we talked about gobbling up? So I would have infinity squared plus 2 times infinity minus 3 over infinity squared minus 1 times infinity minus 12. Okay? Hopefully you can see already the answer is going to be 1 because you're going to gobble, 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 right? So if you approach infinity, what you're doing is talking as x approaches infinity, it should level off. Where's it going to level off at? Well, let's go to infinity and find out. Gobble, gobble, right? Because infinity minus 3 is just infinity, okay? And we're going to gobble that one too because infinity plus 3 is basically infinity. We're also going to gobble up the 2 times infinity because infinity squared is much bigger. And we'll gobble up this infinity because infinity squared is much bigger. So you're left with infinity squared over infinity squared, which is basically 1. So your horizontal asymptote is this. It's going to approach y equals 1. So I go back up to my graph, and I'll let you guys catch up here in a second. Okay. Shift down. I'm going to put in a horizontal asymptote at 1. Okay, now, where's the rest of the graph go? Well, one of the things I know is I kind of have a point already. Now, I'm doing this whole thing without the calculator. Yeah, I can put it in the calculator, which I will here in a bit. But it's going to look something like this. It's going to come. We know it has to approach the asymptote, okay? It absolutely has to approach this asymptote here, right? So it's got to, as it goes to negative infinity, it's got to approach this asymptote. It's going to take a dive down, and it's got to approach this asymptote as well, okay? Now, where's the other half of the graph? Well, probably up here. And we can use our calculator to take a look at it. And so pretty sure it's up here. Makes sense with the asymptote, but let's take a look at it anyway, okay? So this graph, clear that out and put this one in. I'm going to go at x squared plus 2x subtract 3 divided by parentheses x squared minus a 1x subtract 12, close my parentheses and graph it. Okay? So the other half of this graph has to be up here. And again, as I graph it in, it has to, think of your asymptotes as borders. Okay, think of your asymptotes, your orange lines, your asymptotes as borders. As you graph it, they're going to approach your asymptotes, right? They're like borderlines. Okay, so as you get closer here, it approaches this one, it approaches this one. Now, real quickly, let's take a look at a couple of things. The whole. Okay, so if I go to trace, and if I go to negative 3, there's nothing there. There's no y value, right? But if I go a little bit beyond it, 0.55, now I told you the hole's at 4/7. It is, but that's pretty close to 4/7. We can't get actually to 4/7, right? Because there's a hole there, okay? So back and forth around the hole, we get all these values pretty close to 4/7. Add negative 3, nothing. Okay? All right, turn the page because now we want to talk about a slant asymptote. Yeah, go ahead.
Is there any time the gobble up method won't work?
It will always work. Always work. Yeah. Okay. You might get an answer of 0 sometimes, but you can have a slant asymptote going to 0 or a horizontal going to 0 also. Okay. All right. Ready? Now, slant asymptotes. Now, remember this. I'm going to write this down. Okay. If the numerator, that's the top part of the fraction. If the numerator is 1 degree bigger than the denominator, that's the bottom part of the fraction, right? Then a slant asymptote exists. Okay. This is what I like about math. The rules never change. Okay. So if I take a look at this particular problem, you've got an x squared, so it's degree 2, right? And I've got an x to the 1, okay? That's degree 1. If the top part of the fraction, the numerator, is 1 degree bigger than the bottom part, then you're going to have a slant asymptote, okay? Now, how do we find out what the slant asymptote? We do division. We have to divide. You have to divide to find the slant, okay? Asymptote. Okay, you have to divide. So I'm going to have to divide x minus 3 into x squared minus 4x minus 5. Which we could, but hopefully somebody smart is going to say, Mr. Davies, can't we do synthetic division, right? Wouldn't synthetic division be a lot easier? Okay, so if we do synthetic division, we're going to go ahead and say, all right, 3. All right, we're going to go 1, negative 4, negative 5. Remember how we did this? Bring down the first term, bring down the 1. Nice notes. 1 times 3 is 3. Okay, negative 1 makes it negative 3, so we get a remainder of negative 8, right? So our answer would be something like this. It'd be a 1x minus 1 plus a negative 8 over an x minus 3, okay? Now, as we approach infinity, okay, as x approaches infinity, then this part right here becomes 0. This part becomes 0 because you'll get infinity. Remember we talked about anything over infinity is just 0? So our slant asymptote is this right here. That's my slant asymptote. The remainder will go to 0. But this is my slant asymptote. It's the equation y equals 1x minus 1. Okay? Now before I do a whole lot of graphing, I got to go back up to the original because I'm going to have a vertical asymptote somewhere, okay? I'm also going to have a vertical asymptote. Yep. Definitely going to have a vertical asymptote. Where? Where's my vertical asymptote? Where's my vertical asymptote? At 3. At 3. Yeah. Because if x is 3, we will divide by 0. So at x equals 3, we're going to have a vertical asymptote. At y equals x minus 1, we're going to have a slant asymptote. All right, let me go ahead and start putting some things down as far as graphing, all right? Let me take a look at this. So I'm going to go like that, like that. And I'm going to go to 1, 2, 3, right? And I'm going to put in my vertical asymptote for sure. That's going to happen for sure. That's my vertical asymptote. That's where I divide by 0. Now my slant asymptote is basically, you know, start at negative 1, right? Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. It's an asymptote, so I'm going to put it as a dashed line, okay? Okay. Well, what does this graph look like? Well, we could test a couple of points. In fact, I do know for sure. Let me go ahead and go way back up to here. You ready? We're gonna graph it, but let's use some brains. I do know I'm going to have a y-intercept at 5/3. If x is 0, right? If x is 0, think about it. If x is 0, I will have a y-intercept of 5/3. Negative over negative, right? You okay with that? 5/3. So I know for sure if x is 0, I'm going to have a point right here at 5/3. Okay. So now, I have not touched my calculator because I'm pretty sure I can do this without my calculator. Even though, yes, we will look at the calculator, I'm pretty sure my graph from this point has to approach both asymptotes, right? Doesn't it? I mean, so I know the behavior's got to be something like this and something like this. I know that for sure. When I look at my calculator, that is going to happen. My graph has to do this. I found a point that it goes through, and from that point it has to go towards my asymptotes, all right? Then there's got to be another part of the graph over here, okay? Now it's either going to be down here or it's going to be squeezed in here. Now this is where I'd use the calculator. I mean, I could pick a point and get it, but let's graph it. Let's see what this thing looks like, all right? Y equals, let's clear this. Let's go parentheses, x squared, subtract 4x, subtract 5, divided by parentheses, x, subtract 3, all right? Let's check it out, okay? Let's see what it looks like, okay? All right, it was on the other side. So if I take a look at what I just graphed, okay, I was pretty confident about this line right here, right? And there it is. There it is, okay? I was very confident about this line, and it matches up the calculator. Now, this other line, same thing. It's got to approach my asymptote, so it's going to go through. It looks like it goes through at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we got another point here. And it has to approach the asymptotes. Has to. And there it is. All right. Go ahead and stop this recording.